Dr. deGrasse Tyson, I asked Dr. Steven Weinberg once, what did he think about the expanding universe? Was it going to expand forever, or would it collapse into the big crunch? What do you think?
It's not a matter of who thinks what. You look at the data. The data is unambiguous, and he would give you exactly the same answer I'm giving you now, an answer that you didn't reveal to me in advance. It doesn't matter because he'll give you the same answer. All data show that we will expand forever on a one-way trip, and the data has never shown that we would ever recollapse. So the recollapse model was a mathematically allowed possibility in Einstein's general theory of relativity. So you go through all the possible ways the universe can behave while still following the precepts of general relativity. One of them is a collapse. So we are in a one-way trip, which is, I have found to be philosophically unsettling to many people. Because how could you be in a universe that only has one go at it?
But that's it.
Yeah, so what you learn when you study science in general, but astrophysics especially, that you no longer invoke your senses to judge what makes sense, or you no longer invoke your personal philosophies to judge what should be true. The universe is what it is, and it really doesn't care about your senses. Yeah.
You know what he answered? He said, it's going to expand forever unless it doesn't.
Sir.
Thanks for your interview here, Dr. Tyson. I heard a great science joke the other day, and I wanted to see if you had heard it. How many astrophysicists does it take to change a light bulb?
Wow.
You haven't heard it.
6. No, I don't know.
The answer is 2. One to hold the bulb, and the other to rotate the universe.
I've heard that apply to other professions as well. So I don't know if it uniquely applies to astrophysicists, but yeah.
All right, sir.
Hi. I was a physics major at SUNY Albany, and it was...
State University of New York,
New York,
Albany.
Yeah. And it was really, really hard. I wouldn't be surprised if it wasn't for you, but I was hoping maybe you could share as your time as a student and then professor and then lecturer and all that, an aha or like eureka moment, like where something finally clicked for you.
Just in my life in general, or specifically studying physics?
Physics, yeah.
Well, a couple of things. First, there's very little in life that's worth achieving that isn't hard. Those things that are hard because most people can't do it. That's why we say they're hard. If you work at it and achieve it, and you continue that throughout your life, you are distinguishing yourself among others around you by what you have achieved. And those who rise the highest are those who keep solving hard things. And you'd be surprised how intellectually lazy we can become. You go to college and you say, I'm going to take this easy class so that I can get an A. Then everyone will be impressed with my A. Well, A is supposed to be a proxy for how brilliant you are. Well, your brilliance is not measured then by your grade, it's measured by what you actually accomplish out there. So that's why in the most brilliant people out there, you don't ask them what grades they got. Their grades are irrelevant. It's the hard things that they encountered and tackled. Leads me to the famous quote from John Kennedy: we choose to go to the moon, not because it's easy, but because it's hard. Now, my best example for you is not from physics, but from mathematics. I was in high school, and I took calculus for the first time. Calculus is really different from stuff that comes before it, all right? Calculus is more different from algebra than algebra is from arithmetic, all right? And I got the calculus book, and you open it up, and there are these formulae lining the inside jacket in the front and in the back. And it's got squiggly symbols, and half the Greek alphabet is visiting my textbook. I don't know what the letter is. I don't know how to pronounce it. I don't know what it means. I don't know what it's used for. And there it was. And I said, I will never understand this. That's how foreign it looked to me. But day after day, You go through the textbook and you learn a little more and a little more. And then I open the pen. Hey! I know what that is now. That's a derivative on the second variable. Oh, hey! And it was this fog that dissipated. And that was a lesson for me that hard work dissipates ignorance. And I've invoked that in my life ever since. The measure of whether you learn something is not whether it was obviously true to you upon first glance.
That's a good answer.
Thank you. That's very inspirational.
Yeah, sure. Thank you.
I like your NASA shirt.
Oh, thank you. Yeah,
Thank you
it's
for being
topical.
Thematically appropriate. Go ahead. Yes.
I was just wondering if there are any schools of thought or generally accepted ideas that might have flipped in the field over the past century or so. What was the most interesting or dynamic one for you?
Yeah, so flipped, you mean we thought this and now we think that?
Yeah, new data, yeah.
Yeah. So science doesn't really work that way. So there's a lot of misunderstanding about science as an enterprise. And let me just, if I can take this moment
Please.
to highlight. If you perform an experiment that demonstrates the conduct of reality, maybe I don't agree with that experiment because maybe I think you're biased. And you're trying to get that result, and you're either intentionally biased or you're passively biased, but I'm going to doubt you. I'm going to perform that same experiment and see if I get the same result. If I get the same result, and I'm a completely different person, then maybe that result is reality.
It's the ballgame there. Right?
Okay?
Yeah.
Now, but still 2 is not enough because I use an experiment of the same design. A third person comes in and say, I'm not going to use that design because I think that design of your experiment is flawed. Because this is an important result. I'm not going to base the whole thing on just what you got, all right? So now you create a whole new kind of apparatus and you get the same result. Then you have experimental consensus and a new truth emerges about the operations of nature. That truth does not later on get overturned. That's not how it works. What gets overturned are ideas that are not yet experimentally verified. And any research journal is full of ideas that in 6 months or a year will get tossed, modified, reworked, ignored. So people say, oh, science is just one day you want to believe this and then you believe that. And I say, what's your best example? They talk about the flat earth versus the round earth. That was back 500 years ago. Science, as I now describe it to you, has taken on this identity basically since Galileo, 1600 onwards. In that era, experimentally determined truths do not get undone. What happens is, take Newton's laws, for example. He has a law of motion and law of gravity. Then we find out, wait a minute, if there's a high gravity source, Newton's laws fail. If you're moving really fast, faster than a running horse, whatever Newton might have experienced in his life, his equations begin to break down. Do you throw away all of Newton? No, it works in all the other cases. So what's going on? Einstein comes up with laws of motion, his special theory of relativity. Einstein comes up with a new law of gravity, his general theory of relativity. Do they replace Newton? No. They draw a bigger circle around the applicability of Newton's laws. Newton's laws apply here. Einstein's laws take over for the rest of the universe. And if you put in low speeds and low gravity in Einstein's equations, they become Newton's equations. They become Newton's equations. So, given that fact, all I will tell you is a strongly held idea that was not experimentally verified, but everyone was really sure it had to have been true. Then it got overthrown, and that was the luminiferous ether. The idea that sound requires air or a table or some medium through which to propagate. Light, which is also a wave, surely must require a medium as well. But there's the vacuum of space. Clearly, we get light from the sun and the rest of the stars. So what medium is carrying the light? So everybody invented a medium, the ether. Calculated what light must be doing through it. And in the late 1800s, early 1900s, experiments were done to show not only do we not need the ether, light travels just fine through a vacuum, and it propagates in a different way from sound. So our understanding grew, ether got thrown out the window overnight, and we moved on.
Yep. Facts don't change. Just that's it.
Yeah. So that's a long answer. I'm sorry, it took so
No,
long
really good
to
answer.
answer that. Yeah.
And also the answer was basically no, and it was that long.
Yeah, that's what I was, yeah, an expansion.
It's a great
Yes.
question. Thank you.
Yes, thank you.
Sir.
Oh, wait, or,
And there's more.
but wait, or we don't know anything about anything, and then a new idea comes up.
Yeah.
So we didn't know how elements were formed. All the elements on the periodic table, we had no idea. There wasn't even an offering for how they formed. We just knew we were plumb ignorant about it until 1957, when a paper was published called what's it called? Basically, the formation of the elements. And we discovered that elements were formed in the centers of stars. And that transformed modern astrophysics and chemistry. We learned a lot about chemistry from that as well. So that was a new thing that didn't flip-flop anything. It's just added knowledge to our base. So sorry.
Love it.
Okay.
Good
Thank
answer.
you.
Yeah.
We have 4 more. We have a limited amount of time. We're going to try to make the questions
Okay,
fast, and we'll do the
I'll go into
answers.
soundbite mode.
Oh,
How
it's
about
cool.
that?
It's cool.
Okay.
It's cool. It's cool.
Ready,
It's all
go.
good. Go.
Okay, 2 quick things and 1 question. The Austin Astronomical Society sends its greetings and would
Thank
be
you.
very happy for you to renew your membership at your convenience.
All right, that was 1 quick thing. I'll judge the quickness
Okay.
of it. Keep going. Second.
Get that doctor off of my space telescope, Dr. Story Musgrave.
Story Musgrave is a medical doctor, and so what you're trying to do is call me out on the fact that I wouldn't let a medical doctor operate on the Hubble telescope. And Story Musgrave, who serviced the Hubble telescope, is a medical doctor. So what's up with that? Story Musgrave also has 3 or 4, I've lost count, master's degrees in engineering, and it's his engineering background that was tapped to even help design the space shuttle in the first place.
Right.
So,
Shazam.
and there's no indication that Sandra Bullock knew any engineering at all. So there you have it.
Next.
As a former academician, or as an academician, it's particularly appropriate now. Any thoughts on the Seguin effect, where academic research becomes less credible as the researcher becomes more popular?
What do you say about that?
Yeah, so I don't think that's true any longer because, now, of course, he pioneered this. And what I've found is, over the years, the academic community in my field, others are laggards here, I've seen it, geology, physics, chemistry, in my field, we understand that we are healthier when the public embraces what we do,
Right.
and when the members of Congress can converse about frontier astrophysics research with the rest of them. Then budgets go up, everybody's happy. And so this activity has been embraced by my community, and I have independent evidence for that. So no, that concern, while it surely was true one day ago, is no longer.
Not yet.
Yes.
Thank you.
Sure.
Sir.
Thank you.
Go get
I
it.
love you. Quick question. I have a question about the fossil record. When people, non-believers, try to attack the dating system they use for fossils and whatnot, carbon dating and whatnot, is there any validity to that argument?
So these are when you say non-believers, people who like to reject science
Yes.
in favor of their religious philosophies.
Yes.
So these are people who are apparently require data to support their faith. I find that odd, right? Because then it's not faith, right? I mean, if you have religious faith, then whatever anyone says about the world wouldn't matter to you. If it does matter to you, then that's a different kind of contract that you're taking out on information. And that contract is, there could be data out there that would conflict with your religious philosophy, and then you'd have to go along with it. That's not what actually happens. There's a pretense that data matters, and then they filter it, reinterpret it, ignore parts of it, slice and dice it so that it all fits in to the religious philosophy. So it requires blinders in order to make that happen. So with the radioactive dating, which we use with many different elements, carbon is good, carbon-14, we've all heard about that, is good for periods of time that go back thousands, tens of thousands of years, basically into the Ice Age. We can carbon date frozen cavemen and mastodons coming out of glaciers. Then we have other elements used that are radioactive and they decay. Lead is used to date the age of the Earth. That has a half-life of billions. I forgot the exact billion plus years. Whereas carbon-14 is in the thousands of years. So you pick the one that suits the time interval you're interested in, and then you can date those. That's how we date meteorites, for example. Yeah. The people who are in denial of this simply it exhibits a failure in their educational system. That's what it is.
No validity to it.
Of course not.
Thank you so much.
Oh yeah. Okay.
Good. Ma'am.
Hello. I was actually going to ask how you balance being a public intellectual with your work as a scientist, and how your celebrity affects your reputation as a scientist. But that guy, two guys behind me, kind of stole that question.
I can answer. I can put some nuances on it.
I'd love
There's
that.
So first, it's not balanced, right? I've been heavily doing Cosmos these past several years. And so I have in mind that when Cosmos airs and we're done, that I become a scientist again rather than just play one on TV. And so I actually plan to pull back a bit from my public exposure.
No more Jon Stewart, no more Stephen Colbert, none of the...
That is sad to hear.
Well, if it's just the Neil show, then I would have failed as an educator. What I should be doing is making sure others are out there as well, and they have more people in their Rolodex.
Right.
If it's just me, that's cultism. I mean, that's not what I'm, as an educator, that's not what I'm aiming for here. So that's really my goal here. It's not a balancing act. In terms of reputation, it's based on what your publication record is. It's only that. If I don't publish, then people don't think one way or another. If I do, they'll judge it for whether it's good or bad, whether or not I was in public eye. So that's kind of the good thing about how this system works. So no, I'm not worried about that. In fact, I have several invitations to do a research sabbatical immediately after all this, and I'm actually looking forward to some of that. Yes. Okay.
Thanks.
Last one. Quick one. No verbs.
No.
Just all. Yeah.
All right. So I only have like a layman's knowledge of the question I'm about to ask you, but I'll do it real quick. So I had to do a project on galactic filament, and I kind of had a poof moment looking at like a diagram of it and how like those big like columnar structures of galaxies kind of go off into ordered space, and it kind of made me want to ask you since you're here and I'm here. It seemed like a good opportunity. So do you see any? And it might sound silly, but do you see any like intention or anything in like the ordering of the cosmos, especially at that macro scale, or like what do you see into that? Because that was kind of like a poof moment for me.
Yeah. So if intent is an interesting question when imposed on the universe. For the longest while, philosophically, people imagined that the universe was some perfect place. Earth was a haven for life, especially human life, and everything is just right for us. And that would leave you thinking that there's some intent to the universe, that the universe is serving our needs. And of course, this is, as you would suspect, very strong in religious philosophies, where the adherents of that particular religion are sure that they are more special than any other religion, or more correct in so doing. When you look at the large-scale universe and you see these structures, what you have to ask yourself is, suppose all the galaxies were exactly equally spaced, rather than in these filaments and structures. Perhaps you'd be asking the same thing. Oh, is there some intent here? Look how beautifully ordered it is. Ask yourself, is there some configuration of the universe where you wouldn't ask that? Because if there isn't, then the question doesn't actually aim towards a unique answer. If anything you see out there looks like it's ordered to you, then you can't ask the question. You have to be able to ask the question such that if it were this other way, you would reject it. Now, the people who say Earth is a haven and all this, the fossil record argues differently. 97.8% of all life that ever existed is now extinct. That's the sign not of a planet that loves its life. That's a sign of a planet that wants it to get the life the hell off.
Right. That's
okay?
the anti-haven.
Right.
Yeah.
Right. We are alive not because, but in spite of it. From tsunamis, earthquakes, tornadoes, hurricanes, droughts, floods. Every year, they kill thousands of people. Thousands.
You're kind of bumming me out, I have to say.
I'm not done. Not to mention asteroid impacts. took out the dinosaurs 65 million years ago. Earth is in a shooting gallery. You want to say there's intent? Yeah, the intent is to kill us. Okay? There's your intent.
Well.
So the more you look at the universe, the less clear any purposeful intent there is. And I recommend, if you look online, Google my name and universe and the word purpose. And I have an essay that was actually done up on it as a YouTube video as well, where I comment on, does the universe have purpose?
On that upbeat note, we're going to need to.
Wait. You want to upbeat?
Give us
when the asteroid comes.
Yes.
Okay. If we have people who reject the science world, and the asteroid is headed towards us, they will be doing a number of things. Praying, certainly. They'll be running away from the impact point. They'll be buying toilet paper and bottled water. And whereas if you had scientists in your midst and engineers, when the asteroid comes, they say, how can I deflect that? Two completely different outlooks on your fate. So if I'm bumming you out by saying there's disaster that will kill us, I'd like to lift you up again by saying it may be that innovations in science and technology may be the only thing that can save us from ourselves.
You debummed me. That's perfect. All right. Dr. Neil deGrasse Tyson. Thank you very much.